Assalamualaikum and good day to Dr. Yamani and to my fellow classmates. My name is Chairiel Azizi bin Khairuddin.
Hello doctor and everyone, my name is Lin Fanzhi.
And hi, my name is Aina Azerin.
Today we look at lab 6, which is regarding dining philosopher's problem.
The dining philosopher problem states that key philosophers seated around a circular table with one chopsticks between each pair of philosophers. There is one chopstick between each philosopher. A philosopher may eat if he can pick up two chopsticks adjacent to him. One chopstick may be picked up by any one of its adjacent followers, but not both. In computer science, the dining philosopher problem is an example problem often used in concurrent algorithm designed to illustrate synchronization issues and techniques for resolving them.
This is an illustration of dining philosopher's problem. There are 5 philosophers at a dining table. They are given one bowl of rice each and one chopstick adjacent to them. At this table, they are either thinking or eating, and they are not interacting with each other. When a philosopher wants to eat, he needs to take a chopstick on his left and one on his right. But there will be a problem if all of the philosophers want to eat at the same time. Let's look at this situation. All of the philosophers want to eat and they pick the chopstick on their right. Therefore, there won't be any chopstick on their left. So, all of them cannot eat. This is when the deadlock happens. They will be starving until someone put back a chopstick so that the chopstick on their left is available. And then they can eat. Now, let's look at the flowchart and programming explanation.
Okay, now we continue with the flowchart and code explanation for the dining philosopher problem. So first, we will create a semaphore class to represent the forks. So semaphore is a flag that has no negative integer value, and in our problem, the semaphore will signals when a resource is free and when it can be used by a process. So in the semaphore class, we initialize the fork object and we made a construction method. And after that, we will make a synchronous method pick fork and decrease the number of forks. So as you can see here, we have two methods here. The first one is pick fork. So while the fork is equal to 0, so we will then print the fork is in use, which means that all the fork has been used by some philosophers. So we will have to wait until it is free. And then we will decrease the number of fork here. And then we will make a synchronous method put fork and increase the number of fork. So when the resource is free and the fork has been released by the philosopher, then we will notify that it has been free to be used by other processes. And after that, we will create the philosopher class and implement the necessary methods. So you can see here, we have philosopher class. And then in this class, we will make a method named run. So what do we have in the run method here is the in the run method, set the philosopher state, which are thinking, hungry, pick fork, eating, and put fork. So in the philosopher class, we extend the thread to enable concurrency process in Java. So we will initialize the philosopher ID and then the array of forks, semaphore forks. And then in the run method, we will start by the philosophers is thinking, and then we will slip this process in a random number. Then it will the philosopher will become hungry, and then this we will use the method from the semaphore fork class. So if the fork is free, so the philosopher will pick up the fork. But if it's not free, then it will print the fork is in use. Then we will pick this is the right fork and this is the left fork. So Then after it has 2 forks, the philosopher will start to eat. Then we will slip it again. And then after that, the philosopher will put the right fork and it will put the left fork here. Then it will repeat the process. Okay, then in the main method, we declare 5 philosophers and 5 forks. So here we declare the philosophers and we declare 5 forks here. Okay. After that, we will create the forks and assign it to array of sum of our object. Here we create the forks, and then we will create the philosopher's object. Here we create the philosopher's object, and then we start the thread process. Okay, now I will run this process here. Okay, so here we can see here philosopher 1 is thinking for 0 to 3. Then the philosopher 3 start to hungry first. Then he will pick the fork 3, which is on his right, and fork 4 which is on his left. Then he is eating. So philosopher 0 is hungry. Then 0 pick up the fork 0 on the right side and fork 1 to the left side. So then philosopher 0 is eating. And then philosopher 1 is hungry. So for philosopher 1, the right side is fork 1 and the left side is a fork 2. So since philosopher 0 did not release yet, so the fork is in use. So here, as you can see here, philosopher 0 put down the fork 0 and put down the fork 1. And then the fork 1 is released, so the philosopher 1 can pick up the fork 1 and fork 2, and that's how it runs. And I think this is it for the explanation and flowchart. So thank you.